Good evening, class 7, 8, and 9. Magnetism. It is equally important for class 6, 7, 8, and 9. You need the second last chapter of physics, Magnetism, Nepali Chummakatwa. Part 1. Main objectives of this lesson are as follows: magnetic bodies and non-magnetic bodies or materials. Magnetic bodies are attracted towards magnet. Non-magnetic bodies are not attracted towards magnet. Properties. Properties of magnets. See, directive property, attractive property, attraction, repulsion property, etc. Magnetic induction. Just the word induction, making temporary magnet either by touching or bringing a magnetic body near to a magnet. Poles, just like North Pole and South Pole. Magnetic or magnetization, demagnetization, opposite word. Molecular theory. A big magnet is the combination of molecular magnets. Conserving magnetic force. How to conserve magnetic force? Especially by keeping or by using properly or by keeping magnetic keepers. Terrestrial magnetism. Here, the earth behaves as a powerful magnet. Logics means state scientific reasons, differences, uses of magnets. Actually, the first natural magnet was found in Asia Minor. Lodestone or leading stone. Mention some uses of magnets. The first question, and then the second question is properties. Mention some uses of magnets. Magnets are useful for the following reasons. Reason number one, very simple, to show directions. See, especially if you know the north direction, you can easily find out other directions, especially for navy and while people are wandering around the jungle or forest. To show direction, to lift heavy loads by using magnets. Another is to store information, especially videotapes, drives, videotapes. Example: video tapes and magnetic chips, drives, pen drives, etc. They store correction, especially in electronics, computer science. Another very important thing is MRI. MRI. For MRI, magnets are very important. Magnetic resonance imaging. For MRI in the medical field, especially that is in medical field. MRI गर्ने भन्छ नि, MRI, magnetic resonance imaging. Magnets are very useful. Another, to pull out iron particles from ice. To pull out iron particles, very small particles can be put in ice, so they must be removed. Another, to separate magnetic bodies from non-magnetic ones. Sometimes these magnetic bodies must be separated from non-magnetic bodies. By using a magnet, we can easily separate, even if they are particles. Number one, directions. To show directions, दिशा पता लगाउनलाई, to lift heavy loads, to store data collection or information like videotapes, magnetic chips, drives, etc. MRI, magnetic resonance imaging in medical fields, to pull out iron particles, from eyes, to separate magnetic bodies from non-magnetic ones. They are some of the most important advantages of magnets. One important thing is, a magnet is not a magic box. It is not magic. It is neither magic nor miracle. It is science. Remember. Question number 1 is uses of magnets. Question number 2. These questions are equally important for lower class and higher class both. Mention some properties of a magnet. Before I draw one magnet, North Pole and South Pole. Is the middle. Here North Pole is here. Not exactly. This whole is length of a magnet. Length of magnet is from this side to this side. But this one is this one is magnetic length. Length of a magnet is longer, and magnetic length is the distance between the North Pole and the South Pole. In Nepali, length of a magnet banane is one side, whole length, total length, but magnetic length means it is about 85% of the length of a magnet. If it is 1 meter, then from North Pole to South Pole it is 85 centimeter, 85%, nearly 85%. So mention some properties of magnets. What are the some properties of magnet? Magnet चुम्बकले कुन कुन गुणहरू देखाउँछन्? See, mention some properties of magnets. Solution: some magnetic properties are as follows. Number 1, first property is that a magnet shows the north-south directions. North-south direction. Here N for north and S for south. Remember, N for north and S for south. It always shows north-south direction. It is called. That means a magnet here, or magnet means a freely suspended magnet. See, it is better to write a magnet here means a magnet shows north-south direction if it is freely suspended. If it is freely suspended means there should not be any magnetic bodies near it in the magnetic field. Then another word, magnetic field also. A magnet shows the north-south direction. Directive property. Attractive property. It attracts magnetic bodies, magnetic materials, magnetic substances. Meaning same. Magnetic materials like iron, nickel, cobalt or there. Alright. A magnet attracts iron, nickel, cobalt, and the homogeneous mixture of iron, nickel, or cobalt. Either two or minimum two or all three. Either like iron plus nickel, iron plus cobalt, or nickel plus cobalt, or all three. आइरन निकल र कोबाल्ट अथवा तिनीहरूको होमोजिनियस मिक्सचर अर्थात् अलॉयलाई यसले तान्छ नंबर 3 another property like poles and non-like poles repel and unlike poles attract. These properties are found in lower classes also. See, especially these questions are equally important for not only class 8, for all classes. Like poles repel and unlike poles attract. If you toss north and north or south and south, they repel, means they don't attract. Unlike means north south or south north. Here like means same, unlike means different. Another property is like poles repel, unlike poles attract. Another, can you say magnetic strength? The magnetic strength is maximum at the poles. That means North Pole and South Pole are free to attract. So North Pole and South Pole have the maximum magnetic force. The magnetic strength is maximum at the poles and minimum in the middle of a bar magnet. In the middle of a bar magnet. Number 5 is there cannot be one pole or three poles. One pole not possible. Three poles not possible. Only two and only two. Each magnet has two poles. That means North Pole and South Pole. That means they can't be separated. They can't be, North Pole and South Pole cannot be separated. Another is it has a magnetic field. A magnet has magnetic field, the area around a magnet up to which magnetism can be felt. Each and every magnet has two poles. The magnetic strength is maximum at the poles, minimum in the middle. छेउमा सबभन्दा बढी बीचमा सबैभन्दा कम. Like poles repel, unlike poles attract. Each and every magnet attracts magnetic bodies only, but it does not attract non-magnetic bodies like copper, zinc, gold, silver are non-magnetic. They are metals, but they are non-magnetic. Only magnetic materials are attracted towards a magnet, and every magnet shows the north-south direction. It does not show east-west direction. It is freely suspended. Question number 1. Question number 2. Question number 3 is Define with examples if any. That means if there are examples, write examples, first write definition, and after defining, if there are examples, write examples, otherwise not. पहिला डेफिनेसन लेख्ने, एक्जाम्पल छ भने लेख्ने, छैन भने नलेख्ने. Define with example. The first thing is magnet. Magnet and magnetism at a time. Magnet and magnetism. A number is magnet and magnetism. What is a magnet and what is magnetism? We can see magnet, but we cannot see magnetism. So, a magnet is a metallic piece which has the ability to attract magnetic bodies and show the north-south direction. Here I have written only two properties. It attracts magnetic bodies and it shows the north-south direction. It has the ability to attract magnetic bodies and it has the ability to show the north-south direction. That special metallic piece is called a magnet. Here, example, natural magnet, lodestone, bar magnet, electromagnet, round magnet, horseshoe magnet, etc. They are some examples of magnets. And another is magnetism. Magnetism is invisible force of a magnet. Invisible force of a magnet. That means with the help of which it shows magnetic properties like directive property, attractive property, etc. Magnetism is invisible force of a magnet. For example, it has two poles. It shows the north-south direction. It attracts magnetic bodies. Like poles repel, unlike poles attract, etc. A number, magnet and magnetism. B number is pole of a magnet. This is also very important thing. Magnetic bodies, non-magnetic bodies, pole. Dhruva. What is a pole? See. There are two poles of a magnet, north pole and south pole. What is a pole? The edge or side of a magnet with maximum magnetic power, force or strength. If you are confused to write the word strength, you can write power as well. The edge or side of a magnet which has the maximum magnetic strength, the edge or a side of a magnet with maximum magnetic strength is called a pole. For example, North Pole and South Pole. Each and every magnet has two poles. Another is magnetic bodies and non-magnetic bodies. Magnetic and non-magnetic bodies. Magnetic and non-magnetic bodies. Here I have written there are actually two words, magnetic bodies and non-magnetic bodies, but I have written in one. Why? Just to show the differences. What are magnetic bodies and what are non-magnetic bodies. Just by the word magnetic means attracted, non-magnetic not attracted. Magnetic bodies are those substances which are attracted towards a magnet. Just by the word, magnetic bodies are those which are attracted towards a magnet. Example, iron, nickel, cobalt, or their always they are homogeneous mixture of iron, nickel, or cobalt is also attracted by a magnet. They are magnetic bodies because they are attracted. But copper, remember, copper, zinc, gold, silver are metals, but they are not magnetic. Don't be confused with magnetic bodies, but not. They are magnetic bodies and uh, metals both. But all metals are not magnetic. Please see number. Now D, length of a magnet and magnetic length. Length of a magnet and magnetic length. Length, it is in class 7. Just you must have the clear cut concept. To get the clear cut concept, you should know it. But let me draw for the sake of convenience length of a magnet and magnetic length. North pole, south pole. It is actually magnetic length. Magnetic length, just I have shown it to distinguish, and here from one side to other side, length of a magnet. So to distinguish between length of a magnet and magnetic length, first I have drawn a diagram of a magnet. This is a magnet. See, this is the whole is magnet, okay? And here north pole, here south pole. The distance between the north pole and south pole, magnetic length. The distance between two sides, actually pole and sides are the same, meaning same, but in the concept, word meaning same, but concept different. अर्थात् साइड भनेको पोल, पोल भनेको साइड त हो, तर यहाँनिर पोललाई चाहिँ साइड भने तापनि यो नर्थ पोल अलिक यता यतापट्टि हुन्छ. नर्थ पोल एन्ड साउथ पोल lie just a little bit inside. So magnetic length is smaller, shorter than the length of a magnet. So length of a magnet, the actual means total length, the actual length of a magnet is called the length of a magnet. For example, AB. For example, AB. The whole length, the whole total length, actual length of a magnet is length of a magnet. And what is magnetic length? The distance between the two poles of a magnet is called the magnetic length. The magnetic length is the distance between the north pole and the south pole of a bar magnet, whereas the length of a magnet is bigger, a little bit longer than the north pole, and which is shorter. The magnetic length is shorter than the length of a magnet. E number, magnetic field. This is also very important question. Magnetic field. If there is a magnet, it has the property to attract. Outside the magnetic field, it cannot attract. So what is the magnetic field? The area around a magnet, the certain area, the area around a magnet up to which it means magnet, shows magnetism is called the magnetic field. See, the area around a magnet up to which it shows the magnetic strength is called magnetic field. And there are so many others also, like pole magnetic length of a magnet pole, terrestrial magnetism, magnetic induction, demagnetization, etc. Which I am going to write down. E number, magnetic field. F number, magnetization and demagnetization. I have written these two words at a time just to distinguish and to avoid confusion. Magnetization and demagnetization. The process of making or making a magnet is called magnetization. It can be made with the help of electricity, by stocking method, single toss method, double toss method, electrical method. And demagnetization, just opposite word. Demagnetization is the process of losing magnetism. How to lose? For example, touching like poles, dropping frequently, dropping it frequently, खसालेर, hammering, passing alternating current. One thing, passing alternating current loses the magnetism. DC maker, AC breaker. One thing, DC maker and AC breaker. What is the meaning? DC maker and AC breaker means if you pass direct current to any solenoid or any iron particle or any magnetic material, it becomes a magnet. If you pass alternating current to any magnetism, the magnetism breaks. DC ले बनाउँछ, DC maker, AC ले बिगार्छ, AC breaker. DC maker, AC breaker. DC maker, AC breaker. You have to understand this. By passing alternating current, other rough handling, uh, by burning, by heating, etc. These activities demagnetize, and magnetization by passing current, direct current, or by stoking method or EF. G. Lodestone. Lodestone, the first natural magnet, the first natural magnet found in Asia Minor by the Chinese Navy, by the Chinese or Greek Navy, Chinese Navy. In some books, Chinese Navy is written, but in another book, Greek Navy is also written. Asia Minor by the Chinese Navy is called the lodestone or leading stone. Fesophil, Fe3O4. Its formula is Fe3O4, triferric tetraoxide. It is the first lodestone. It was at first used to find the direction. It is used to find the direction. Lodestone is very important. EFG. Magnetic induction. The word EFGH. Another word is magnetic induction and electromagnet. Magnetic induction, it is the process of making a temporary magnet by bringing a magnetic body close to a magnet is called magnetic induction. See, suppose it is a magnet. Suppose this is an iron piece. If you bring an iron piece, suppose magnetic body very close to a magnet, either by touching it or bring it very close, and it becomes a magnet. This magnetic body becomes a magnet if you touch it, either touch it or bring very near to it. Then this process is called magnetic induction. अर्थात् म्याग्नेटको नजिकै एउटा म्याग्नेटिक बडीलाई ल्याएर टच गरेर वा नजिक ल्याएर टेम्पोररी म्याग्नेट बनाइन्छ भने यसलाई भनिन्छ म्याग्नेटिक इन्डक्सन. Another is electromagnet. The magnet made by passing electric current. Here direct current. The magnet made by passing electric current or DC to a solenoid is called an electromagnet. It is temporary and powerful. It is temporary but more powerful than other magnets, electromagnet. There is, other words, molecular magnets are magnetic domain called molecular magnet or magnetic molecule or magnetic domain. एउटा म्याग्नेटलाई जतिसुकै सानो टुक्रामा टुक्राउँदा टुक्राउँदा बरु सबैभन्दा सानो टुक्रालाई भनिन्छ मोलिकुलर म्याग्नेट or magnetic induction, magnetic molecule or magnetic domain. You can break a magnet into smaller and smallest possible magnets, and each and every magnet behaves as a magnet. So it is called molecular magnet. Just like the earth is also molecular magnet, magnetic molecule or magnetic domain. It is the smallest possible magnet showing all magnetic properties. This is called molecular magnet. Even if a big magnet, you can break a big magnet into two. See, you can break into two. Again, smaller and smallest. Finally, smallest possible magnet. You can break one magnet into two, 2 into 4, 4 into 8, 8 into 16, 16 into 32, and infinite numbers are smallest possible magnet, and each and every smallest possible magnet has all magnetic properties. It shows all magnetic properties. Electromagnet, molecular magnet or magnetic molecule or magnetic domain. It is also called the magnetic domain. GHIJ. K number possibly the last. Terrestrial magnetism. It is found in one book. Terrestrial magnetism. What is the terrestrial magnetism? The property of the earth as a powerful magnet. The property of the earth as a powerful magnet or magnet is called terrestrial magnetism. Means the earth has a powerful magnet. What is the reason behind it? Scientists guess or speculate. Speculate means guess that there is a continuous flow of electrons or electricity, say electricity inside the earth crust. See, if there is electricity flowing, magnetic field is produced, magnetic field is developed, and due to the magnetic field developed, the earth also behaves as a powerful magnet. यो अर्थको क्रस्टभित्र कन्टिन्युअस फ्लो अफ इलेक्ट्रोन्स हुन्छ, इलेक्ट्रोन फ्लो भइरहेको छ, त्यो इलेक्ट्रोन फ्लो भएपछि म्याग्नेटिक फिल्ड बन्छ, अनि त्यो म्याग्नेटिक फिल्डले अर्थलाई पावरफुल म्याग्नेट बनाउँछ. देयर इज कन्टिन्युअस फ्लो अफ इलेक्ट्रोन्स इनसाइड द अर्थ क्रस्ट, एन्ड वेन देयर आर इलेक्ट्रोन्स फ्लोइङ देयर इज म्याग्नेटिक फिल्ड produced, or the magnetic field is produced and due to the magnetic field produced, the earth also behaves as a powerful magnet. Next time I'll do some more. This much for today.